Greetings from Goblin Valley, Nissedal, Norway. I'm here, so you don't have to be. Today's introduction is really short. This is a continuation of my video about airflow in RDAs, and please watch that first, because today we are going to talk about fine tuning. And believe it or not, if you place your coils 1 millimeter or a half millimeter too high or too low, will actually have a great implication for your flavor experience when you are vaping. So let's just watch videos for the rest of this video. Because it's much more fun to watch live video, I will do that while we go through this introduction and talk about what we see and what you might expect from this video. So this what you're seeing now is just well, call it the background. This video is not for you who uses coarse Clapton coils or twisted coils or stapled Claptons. All of you who uses coarse coils with transversal lines that will catch the air and create turbulence immediately, this video is not for you. There is not a single principle that will benefit you in this video. So who is it for? It is for all of you who uses Clapton with 40 gauge wrap wire or thinner, and if you use regular round wire or round wire in parallels, and of course you who have started using flat wire coils. The reason for this you will find in my Clapton flat wire coils versus Clapton coils part 3 with airflow over actual coils. Now just to orientate ourselves in the chamber, this is scale 10:1. So each square you see in the background is 1 square centimeter. And the coil is then of course a little above 4 centimeters in diameter. The vacuum cleaner is going 3 centimeters to the right of the coil and straight above it. The air is coming in 6-7 centimeters in from the left, and I'm using different kinds of holes and shapes of them, and I will not tell you what kind of holes I'm actually using. That is because I use different kinds because I'm always curious. But there is vapor coming in from the left, and the air is sucked out of the chamber on the top. And the speed this is going, I have measured the speed at which we vape, and I have calibrated the vacuum cleaner to create the same conditions in the same speed. So this footage we are watching now is just me exploring the different kinds of paths the visible vapor takes over a coil when you have a slightly wide airstream. I'm just exploring how the air behaves when suction is coming from the top in various scenarios. The thing we are going to look at basically is something called drag. So we will go to the more concentrated air openings and airflows and look at how we can fine-tune our flavor by positioning our coils a millimeter up or a millimeter down. But of course I have a movable air opening, and yeah, that took some figuring out, but I have it, and that is what we will watch now in a second. Drag has a lot to do with flavor, and I discovered that when the air is coming, as you can see now, high up on the coil, you can see on the other side of the coil the air is going down in a stream, and the lower the jet of air comes, the more the air is straightening up. And in the next clip, when we go below the center line, you will see you can actually guide the air jet up to where the suction comes from. And this principle is familiar for you who enjoys baseball and especially pitchers, because of the 3-seam, 4-seam kind of architecture of the baseball. In a knuckleball, the ball turns half a turn from the pitcher to the catcher, and you have 3 different positions of the seams. They work like tripwires for the airflow. So a knuckleball changes direction 3 times because the drag changes direction. And that is what you see here. If the air comes in high on the coil, the end jet on the other side goes down. If the air comes in below the center line, the drag behind the coil shoots up towards where the suction comes from. And that is something we can use in flavor. Because if you, like now, you have the jet coming in from the top, the air shoots down and it will go turbulent below the coil, and the vapor will get denser. So the flavor will be a bit hotter and more concentrated. And when you put it below the center line, and the air goes not straight up but upwards, then you can run your coils a bit hotter and you can have much more crispier flavor notes, the high notes, the medium notes. It's a much more broad palette of flavors when you achieve that effect. Yeah. This is a goon style simulation with positioning, or in this case I moved the inlet of air up and down. And the block blocks off the air, and you can see now the air shoots almost straight up because the air comes in below the center line of the coil. But the trick is with a goon style deck with the big center block, you can really achieve some dense clouds, because once you cross this center line and go slightly above it, the turbulence goes backwards underneath the coil, or it splits in 2 to be more precise. And creates a very different flavor characteristics. As you see, the turbulence drifts up all the time. You see there is no flow up to the vacuum. No flow. You see it's only drift upwards. Flow is what comes out of the air hole to the left and circumnavigates the coil. and it circumnavigates the coil and hits the block to the right. And if the direction of the flow leaving the coil is even so slightly upwards, you get an effective turbulent drift. Effective turbulent drift upwards. You have drift and you have turbulence, that is chaos, but you can also have turbulent drift. And that is what we are seeing samples of here. It can go up or it can go down. And the flavor is very, very different in these two types of scenarios. This is your typical velocity style deck scenario. This is your basic, you can get a clone for $5. It's a hole in each side opposing each other, and there is an open deck with two posts in the middle. And that's about it, really. Now, as you can see, if you have we have visible vapor coming in from the left. From the right, there is a identical hole coming in with clear air, and you see the clear on the left coil. You see a clear area on it on 3 o'clock, and that is the opposing airstream letting go of the right cylinder and heading the left cylinder at 3 o'clock. And if the air comes in at 3 o'clock, 9 o'clock on these two coils from each side, you have the vapor actually splits in two in the center of the two coils. You have chaos going down and chaos going up. If the air is below the center line, there is drift upwards immediately. But now remember, I do not regulate the airflow on the right cylinder. So this picture is asymmetrical, but still you have a lot of drift upwards. But let's wrap this whole thing up with looking at a perfectly, what I call perfectly aligned coils with perfectly aligned airstream, and let's have a look at how that behaves. This is the last clip I'm going to show you. Please focus between the two coils. Look at that updraft. Because the flow is coming below the center line on both sides, there is hardly any turbulence below, but a ton of it, of vapor, above the coils. This will give the most fantastic, crispy, high note, medium note flavor you'll ever experience. And for a very cheap amount of money. Of course, you can manipulate this to get more turbulence below them and denser clouds, and you can do all kinds of stuff. But you see, by positioning the coils 0.5 millimeter too high, instead of hitting 9 and 3 o'clock, go for 8:30 or 3:30 if you really can pinpoint this stuff. So that's the slightest difference, but in flavor, oh boy, it's big. So experiment and try this for yourself.